specifically focus around the whole concept of a multi-cluster environment. So that's n number of OpenShift clusters, and each cluster can be of a very specific version as long as it's of OpenShift 4.12 and above. So let's go ahead and get into it. Scan my QR code and you'll be able to download the presentation and as well get this video recording as well. So let's talk about some of the agenda and some of the items that we're gonna focus on. So the first one is, what is the role of a load balancer within OpenShift? And that's the prime focus. We're gonna differentiate what we do and why are we partnering. We're gonna talk about traffic management and something called ingress sharding. It's a new term, but I kind of pulled it and picked it up yesterday directly from Red Hat's docs. And so ingress sharding is very similar to route sharding. It's almost the same thing, but I like the concept of sharding because it's more of a Red Hat term. It's more of a concept of what we're doing specifically with HA proxy and sharding of the ingresses across the different clusters. And then the third is to focus on not just providing or steering traffic to a cluster, but steering traffic to multiple clusters. It's n number of clusters. So as we see environments growing, instead of potentially maybe upgrading, which is fine, you can totally do that, why not stand up n number of clusters and just distribute traffic or shard traffic to the different clusters. So this means that when you're ready to move or when you're ready to upgrade, maybe it's just bring down the cluster and restand up another cluster. Because provisioning of clusters, I think, is actually pretty simple today. And so that's the whole concept of distributing traffic, and then we'll talk about some of the options. So let's go and take a look at traditional load balancing. So one of the things that makes F5 really what F5 is today is providing traffic management or steering traffic into the cluster. And that's really what we do well. And so because F5 sits outside of the cluster, F5 can direct traffic and provide traffic management to an OpenShift cluster. What F5 can do at that point is send traffic directly to the node using node port, or send traffic directly to a pod using more of an L7 type environment. It's really up to you. It doesn't really matter. You can do a node port or a cluster IP. The biggest thing that we've been able to solve today with the F5 is being able to communicate directly with the pods using OVN Kubernetes. The biggest advantage of OVN Kubernetes is it gives us direct access to the pods just with simple routing. And so that was one of the big concepts that we had to remove. Now, the unique thing about the architecture of the big IP is the concept of being able to do advanced services in front of the cluster. That means that we can potentially secure the cluster outside, remove any traffic that is unwarranted, unwanted from getting into the cluster, and then once we're within the cluster, we can apply cluster security as well. So for example, pod security within the cluster. There's a bunch of other security options that you can use Red Hat for here, but what we can do is we can firewall traffic through F5's WAF solution. And what we also do is we act as a full proxy, so we actually proxy traffic into the cluster. So it actually prevents unwarranted traffic from getting into the cluster. So again, the choice is to be able to provide traffic management to any service. It doesn't really matter what service it is. It could be of an HA proxy type service. It could be of a Nginx ingress controller. It could be any type of specific service, or we can send traffic directly to the pod. This works really well for TCP-based applications that are not specifically of HTTP. But you can do both. You can maybe go HTTP to an ingress controller and TCP traffic direct. So this is the traditional architecture. We've been doing this for years. This is with F5, Red Hat, Nginx. We have this in production. There is lots and lots of customers that are doing this. But let's talk a little bit about where we're taking this today. So I'm going to introduce a concept of single architecture or dual architecture. And so when you're going F5, big IP to pod, it's really a one-tier architecture. Now, that might work well for your environment. The challenge with a one-tier architecture is that you are looking, or you're managing all of the routes. If you've got thousands of routes, then that architecture might not work. You might need to go to a two-tier architecture. So you're breaking up the personas, more of your NetOps and more of your DevOps. So we have a very limited subset of API calls to manage your big IP to your HA proxy, for example. It might be just a few routes, and then between the HA proxy or between your Nginx to your pods, you can scale as many services, as many routes as you want. And the whole goal here is to scale that horizontally across multiple clusters or n number of clusters. So start with 2 and then span out. And so now that what we do is we bring this concept of sharding, or ingress sharding, or route sharding, where we can actually start and say, okay, shard.com can go to pod A, and this is, in this case, this is, for example, HA proxy. And this is a simple route. So it's an L7 route. So shard shop can go to pod B. It's just a pod, it's just a service. And again, this could be HA proxy again, or it could be Nginx. It really doesn't matter. The big IP just sees this as an endpoint. As long as the endpoint's available, it will then forward the traffic. So we're just doing traffic management. So you can kind of see here, checkout is going to shard C, and account.sharding.com is going to shard D. Now, why does this work? This works really well because this scales traffic management across a single cluster within the cluster. But now, what happens if I want to go ahead and roll out multiple clusters? You can do that, and you don't have to change the logic out here. The changing of the logic is within the cluster. So we'll go and take a look at that. So this is the whole concept of sharding, and you can see right here, this is an example of using HA proxy. It's an example of using an Nginx, or for example, some API call, or maybe something like Istio. It really doesn't matter. However, most of our users are using HA proxy, so that's something that we're recommending. And so you're going to see a lot more here with ingress sharding across HA proxy with big IP as the gateway, and now you're going to see multi-cluster ingress sharding, and that's coming up next. So let's go ahead and focus on multi-cluster. So today, traditionally, if you had to roll out a multi-cluster solution, what you would probably have to do today is you would have to have multiple ingresses. You would have to have a virtual for one app, and a virtual for another app, and maybe a virtual for the third app. And maybe that's not so great because that becomes difficult to manage. So for example here, virtual 1 would be this cluster, virtual 2 would be this cluster, and virtual 3 would be this cluster. This is what most organizations that are doing multi-cluster would do today. This is not preferred. Again, the time that it's going to take to manage the load balancer for 3 different clusters is difficult. So what we want to do is we want to do more of a ratio based, where potentially we start moving into more of a concept of creating a single public IP facing virtual or route. One single virtual route that then ratios the traffic across the different clusters. So for example, you see, you can go to any of these applications, for example, in cluster 1, cluster 2, or cluster 3. So this is now getting into the whole concept of A/B type deployments and ratio type deployments by just simply rolling out X number of clusters. So for example, maybe 4.11, maybe 4.13, guess what? 4.14 has been released. Stand up a new cluster, go ahead and provision the application out there, and have the F5 traffic manager distribute the load. If you want to take this cluster down, you can take it down for maintenance. You still have your applications active in your second to third or n number of clusters. So now what you have is true traffic management across the clusters. With this, we're going to introduce a new concept or a demo that I've actually recorded. So here's an active demo where what we have is that we have a controller within OpenShift that is actually providing the traffic distribution between these 2 clusters. In this example, I've used Nginx, but remember, it can be any ingress controller or it can be any router. So for example, I can take these Nginx out and I can use HA proxy. And there is going to be a demo coming up in a week or 2. We've actually just presented this. So this is an ingress controller. This doesn't have to be Nginx. HA proxy is fine, or of another type of service. But what's happening here is Big IP is distributing traffic to the pods. So these applications are similar. They have the same deployment manifest. So for example, Coffee and Tea pod are deployed in both clusters. And so what you're going to see here is distribution of traffic between the two clusters in a weight or a ratio, or just a load balance. So you can basically use an algorithm to send the traffic between the two clusters. How this works is this orchestration here is going to monitor in this two-tier architecture, this application is going to monitor the Nginx Ingress environment. And so here it's got 3, here it's got 3. These 6 Nginx instances will actually show up on the Big IP device. So what will happen is there's going to be a public IP, and there will be 6 endpoints. And you will just go to any one of those endpoints. How are we able to achieve this? We had to rethink a few things. To be able to achieve multi-cluster significantly and easy, we had to remove the difficulty when it came to networking. So working with Red Hat over the last year, this has really been 2023. We've been able to remove the difficulty using OVN Kubernetes. So what OVN Kubernetes allows Big IP to do is just route the traffic to the network node, and then it gets encapsulated into the OVN Kubernetes mesh. It's route to node, but it's not of node port, it's of cluster IP. So we're not doing anything, we're just routing to the node. So why is that so easy? It's easy because Big IP can act as a router and just send traffic to the node and let the node send it to the pod across the OVN Kubernetes encapsulated network or across Geneva. And that's why this is so significant. So here we have 2 clusters. We have a 413 and we have a 411 cluster. You'll see what's different is the different pod networks. So the pod networks are different. We don't really care, to be honest with you. And as long as you install a new cluster with a new pod network, you're fine. Why do pod networks need to be different? Because Big IP is a network device that's going to send traffic based on its pod network. And as long as you're using OVN Kubernetes, we just see the OpenShift node as a downstream device, as a downstream layer 3 device. For this pod network, we will send all traffic to OVN, and then it will get routed. So this is a huge improvement. The setup of this through a service provider would have taken a long time using tunnels, for example, VXLAN. But to simply be able to route, a service provider was able to set this up in literally less than a day. And so that was new for them as well. And so this moving into 4.12, 4.13, 4.14, using OVN Kubernetes as a default, has been able for F5 to meet this multi-cluster. So what is the difficult thing about multi-cluster is that the automation in one cluster has to monitor the informers or the services or the endpoints of the other cluster. So how do we do that? We use something called CIS, which is a Big IP automator or controller. And what CIS is doing is it's using simple kube config. So take the other clusters and just get their kube config and just create a secret in the primary cluster. CIS the orchestrator will use the kube config to be able to monitor informers of the remote clusters. It's that simple. So we've been able to do multi-cluster without exposing or preventing certificates from having to leave the clusters. The certificates still live within the clusters, and you can see right here, these certificates actually, or the kube config environment actually lives within the secret itself. So you can secure this just how you're doing this today. But CIS is using kube client to be able to access the remote clusters to learn about their status. So a very simple way of being able to deploy or install the Big IP orchestration inside OpenShift. You can use an operator. It's the same thing with Nginx, because Big IP is steering traffic to Nginx. To be able to install Nginx, just use the operator. There are operators for both Big IP controller in OpenShift as well as Nginx Ingress controller. So you can use the operators to be able to install. It's very, very, very simple. There's really nothing to it. And of course, the last is to create the shard. So let's take a look at what the route shard looks like, because I think this is the last piece. So you can access this, but this is what it looks like. So you can see right here, it's a very simple route. So this is the route that creates the Big IP that then distributes the traffic. It's very simple. we have a namespace and we have a host. And what we're doing is we're basically just saying pass through traffic from the big IP directly to Nginx. But here is the important piece. There's an annotation for the remote clusters. So what it's saying is I want you to also monitor the same service, but not on just the primary cluster, but also monitor on the remote cluster. And so at this point, the controller goes out, accesses the secondary cluster or n number of clusters using Kube client to be able to pull the status of this service. So if this service is not there, what we'll do is we'll pull the IP from the big IP. And so that is the route. And then what we've also done here is we've combined the HTTP route with the concept of a kind of like a gateway configuration. We're not using gateway API just yet, but we've taken the route and then we've used a config map or an extended config map to provide us the capabilities of expanding the function of routes. So that means that we can have multiple public IPs assigned to different functions. So you can see here's one OpenShift router, here's another OpenShift router. So this public IP is for this service, for this route. Simply just expanding the config map to give us high availability for multi-cluster. You can see right here, primary cluster, there's the secrets. Secondary cluster, there's the secrets. And so what you can see is we have 3 pods of Nginx in each cluster, and what you can see on big IP is 6 endpoints. And so what will happen is that you will distribute traffic to any one of these 6. So now you're scaling traffic across 2 clusters, but again, this can be n number of clusters. And so big IP is just routing to the node, and then the node will encapsulate that into using OVN Kubernetes. You can see that the load balancer sees the pod IP. So we're using cluster IP here. But for big IP to get to this pod, it's using OVN Kubernetes to route to the node. And so routing to the node, we're not introducing any latency. There's no tunnels between the load balancer. It's just simply just routing. So you can actually see now, if one of these pods are removed, then we will automatically remove. So for example, if I take down one of the clusters, then these 3 will be removed. If you need additional Ingress controllers, then you can scale that up using a simple Kubernetes scaling command. It's very simple doing that. If you want to bring another cluster, then you just add a 3rd, a 4th, a 5th cluster, and then just monitor that Ingress controller in that 3rd, 4th cluster. And so that's where we're going with this solution. So this is fully GA. This is fully supportable from both Red Hat as well as F5 as well as Nginx. And so at this point, you can get full support for a solution like this.